a chart up on the board that would show like how many people are happy or not? Like, you know, yes or no. It was like, do you understand? Yes or no? People are so hesitant, especially on the first day, to be vocal. Everyone here is afraid that, you know, they're going to look stupid or something. We all struggle with math. All of us struggle with math. Nobody in here is perfect at math, all right? We all do. It's you learn by making mistakes. You have to make mistakes. But the biggest lesson that you can learn in any math class is persistence. You have to be persistent. If you're not persistent, you're in the wrong field, right? Somebody? Oh, it should open. Hey, what's up? I think I need you to just at least sign in so I know that you were here. Math 1414? Yes, okay. Seat-wise, I don't know. Good luck. There's a few out there. All right, let's try, what, persistence, right? That's what I was saying, persistence. If you're the type of person who gets a challenge in front of you and you're like, nah, then you have to kind of rethink whether or not you really want to do STEM, because STEM is all about problem solving, overcoming obstacles, your own mental obstacles. That looks horrible, doesn't it? No? Some of you are like, nah, not really. That's fine. So many different ways to start here. So many different ways. Here's one property that I haven't put up here. I have all these damn boards everywhere. Let me use another one. We asked, this building is relatively new, right? I think it's only a year or so old. And last year when they opened the building, we were like, there's not enough boards in here, because all they had was that board, and then they had a couple of these rolly ones. So we said we need more boards. So they put a bunch of rolly ones and they put all those boards on the back, but it doesn't really help me because I film the class, so I have to kind of stay up here. All right, here's a property. Which one are we on? 9? Okay, property 9 is going to be if you ever have a fraction raised to a negative power, then you can basically flip the fraction over and make it a positive power. So it reciprocates the fraction, and then you just use it as a positive exponent instead. Can everyone see that? Now the reason I'm saying that is because I see right now that I have a negative power out here, so I could just flip everything over if I wanted to, couldn't I? Just flip it all over and make that a 3. That would be one option, right? Another option before I do that could be to make this x to the negative 2 go down and make the y to the negative 2 go up before I flip anything over, right? So many choices. I'm going to choose to do the latter, the second one I said. I'm going to bring the x to the negative 2 down, bring the y to the negative 2 up. So my next line will be, or my next statement will be, all of this 5, I brought the y to the negative 2 up. It comes up and becomes y squared. And on the bottom, the x squared comes, or the x to negative 2 comes down, and I still have negative 3 out here. Again, the 5 is not being raised to negative 2, so it does not go anywhere. This 6 is not being raised to negative 2, so it does not go anywhere either. Yes?
How many times can I do this?
Do what?
That process that you just did.
Well, you want to make the exponents positive, right?
Yeah.
So just until you get them positive, you probably don't want to do anything else now. But I do want to get that to be positive, right?
Right.
So I'm going to use that property and flip the whole fraction over now, right? How does, okay, I'm using the property, here we go, that if you have something to a negative power, it moves down, right? I didn't put it here, but this property can be extended. This property can be extended that if you start out with something to a negative power on the bottom, you can move it up and make it like this. So if you have something to a negative power and it's already in the denominator, you can just push it up to the numerator. Yes?
I have a question.
Yes.
Did you get like 2 different answers?
Would you get 2 different answers? How?
Between, so the process you did, you switched the what's it called? The x and the y.
Boom, boom, yep.
And then you still got to flip
I've got to flip it. You're saying
to flip it all, like
first?
wouldn't the 6 be the
Yeah, let's see what happens. Let's see. I know what you're saying. We'll flip it first after I do this. So now we flip, right? Now we flip. So when we flip, it's now 6x to the second over 5y to the second, or squared, and then all to the third. We all agree with that? According to property 9? All right, now that is we have no negative exponents anymore, right? No negative exponents. But I should probably apply the cube to this, which means I'm going to use property 6, that the cube has to go to the top and bottom. Okay, let me write that down. So if I write down, I'm going to take the entire numerator, 6x squared, all of that needs to be cubed, over 5y squared, all of that needs to be cubed. Y'all see? Yes?
Couldn't I just multiply the cube by each one, by both the numerator and denominator?
Multiply the cube. How do you mean multiply? What do you mean by that?
3 times 2 on the top, 3 times 2 on the bottom.
Yes? But you still have to do the 6.
Right.
Right? The 6 still needs to be cubed.
Okay.
Right? Not 6 times 3. So I'm going to do that. I'm going to do that on the next step. Just want to make sure everyone's following where I am. Yes?
Yes.
Okay, now I'm going to use, what am I going to use now? What do you think I'm going to use now? Anyone see what I'm going to do? Which of these properties am I about to use? I can't use this quite yet because I don't have something to a power, right? This 6 is not being squared, right? So I need to use property 4 first, right? I have something, 2 things multiplied. Are these things being multiplied? Are they raised to a power? Yes. So I need to take the power to each one of those first. And then I'll do the same thing on the bottom. So I'm going to do 6, I've got to cube it. I've got to take the x squared, I've got to cube it. I've got to do the same thing on the bottom. I've got to take the 5, I've got to cube it. Then I've got to take the y squared, and I've got to cube it. That is property 4. Now I can use property 5, right? Now I can use property 5 for which parts? The x squared cubed and the y squared cubed. What about the 6, this one right here? It's not 18, right? This is not 18. This is 6 times 6 times 6. 216. This is 5 times 5 times 5. 125. So I should get 216, which you could use your calculator if you need to. 6 times 6 times 6. X to the 6th, and then over 125, and then y to the 6th. So I don't have those clickers. Show of hands. Don't put your hand up if you're struggling, okay? And then like the higher you raise your hand, the better you feel. So if you're like this, you're like, this is no problem for me. So where are we? Where are we? Okay. So I see a lot of like right about here, not a whole lot of these. Okay. All right, just trying to get an idea. Look, I'm here to try and help you, right? This is a review, right? This is a review. So I'm trying to help you get up to speed here. It's easy to come into a college class and just like bulldoze through the class, right? And just lay waste to everybody. But I really want you to succeed here. So I'm taking my time, right? Do we want to see this the other way? You were saying it would be different if we did it a different way?
It's the same.
It's the same, right? Yeah. And that's the beauty. If there is a beauty in math, that's the beauty, right? We should all get the same result. Like it shouldn't be like, well, I did it this way. I got this answer. You did it your way. Well, which answer is right? Well, we couldn't have the things we have these days if that's the way math worked, right? Okay, so I believe that concludes our review of exponents, right? Exponents. I encourage you to work through those problems that were given on that assignment. But if you're struggling with this, right, your assignment only says to do 87, 89, 91, 93, 95, right? you can find additional problems in the ebook itself. Like if you go back further in the section where they cover the concepts, you can find other examples. So if you're unsure, make sure that you go and do more problems. Oh no, I'm erasing the properties. I don't think we need the properties anymore right now. These are not the only properties of exponents. There's more. All right, next topic here in the review is that we're going to practice evaluating expressions. So before I do one of those, I want to give a problem that I like to give in my algebra classes to see what students get. I want you to do 16 divided by 4 times 4. That's me? Yeah. All right. Everybody good?
Yeah.
Everybody have an answer?
Yes.
Okay. You feel good about your answer?
I kind
Or because I'm asking, now you're wondering? So I'd like a volunteer, somebody to volunteer their answer. Go ahead.
It's either 1
What?
or it's 16.
It's either 1 or 16. Okay. So, but are you committed on one of those or
If you
no?
go left to right, it's 16.
Okay. So 16, you're saying 16 or 1. Yes?
Yeah.
Any other answers? Anyone else have something other than 16 or 1? Okay, let's take a vote. 16. How many of you are good with 16? Feel good about 16? 1, 2, 3, 4. 4 people? 5? 5? 6? 6. Okay, so we have 6 students think this. And then I want you to vote, okay? How many of you voting for 1 then? Look around, right? Look around. That's everyone else, right? I think that's around 20, 21 or 22 students, something like that. All right, so for those of you who, the 6 of you who got 16, who wants to tell me your thought process in that? You said left to right.
Yeah, multiplication and division have the same priority in the equation, so you do left to right if it's that way.
Okay.
But if you did multiplication, like if you had priority on multiplication, like if it was in parentheses or something, you do 4 times 4, then you get the 16 by 16.
Okay, I understand what you're saying. I'm okay with that. How about someone from the 21? You want to share? PEMDAS. PEMDAS. What does PEMDAS stand for? This is what we use in math to help us with order of operations, right? It tells us the order in which we do things. The P stands for what? Do everything in parentheses first, right? This parentheses actually could mean do everything in a parenthesis first, or everything in a bracket first, or everything underneath a radical first. Okay, parentheses is kind of more than just parentheses, but we get the idea. Parentheses first, then any exponent. So if you have something squared or something cubed, you do that. Then multiplication, division, addition, subtraction. That's what these stand for, right? So the people who got 1, which is almost the majority, well, it's a strong majority of the class, what they did is they said, I'm going to do the multiplication first, right? And if you multiply these two first, you get 16. And 16 divided by 16 is 1, right? So I see where you got that. And I understand it comes from this because you were taught this, right? So one of two things is wrong. Either you were taught wrong or you don't remember it correctly. One of those two things. PEMDAS is PEMDAS. But when you get to the MD, the multiplication division, it is not multiplication before division. It is not division before multiplication. It is whichever appears first as you read the expression from left to right. So these have equal priority. These are left to right. Left to right. Like you read a book. And same with addition and subtraction. It's also left to right. Anytime you see addition and subtraction within an expression, you always want to work from left to right. So the reason why we have to have an order of operations is so that we don't get two different answers, right? You don't want to get two different answers. Everyone needs to get the same answer. So this little, is that an acronym? I'm not an English major. I thought an acronym had to spell out a word, no? Maybe not. It's called something else. So this is an acronym that helps us remember it, but the problem with this acronym is that it makes you think multiplication is always before division. It's not. So the correct answer here is 16, because you have multiplication and division, right? And so you just go from left to right. So you start with this, you do that, 16 divided by 4 is 4, and then 4 times 4 is 16. So look, a majority of the class learned something today, right? Or relearned it, or however, yeah? Okay. Now let's get on to this problem over here. That wasn't to make you feel bad. I remember being in a class, I was in a college class, and I was shown that, and I got it wrong. And I was pissed, because that meant I either learned it wrong, which is most likely the case, or I didn't remember it right. But I would have thought my teacher would have really stressed that to me, you know, so I don't mess it up. But anyways, okay, so here's what we got here. They're saying in these problems, let x be equal to 2 and y be equal to -1, right? They're giving you the value of x and they're giving you the value of y. That's in the instructions. And then they're asking you to evaluate this. So let's do 98. Find -3, x to the -1, y. And let's do y squared. I'm going to change the problem a little bit. Find this. So all I need to do is just replace x with what? 2, and replace y with -1. Right? That's just plug in. So I'm going to rewrite this. It's going to be -3. Okay, to be safe and to make sure that nothing bad happens, I'm going to put the x, whatever it was, 2, I'm going to put in parentheses and then raise that to the -1. And then I'm going to take the y, which was 2, and I'm going to raise that to the 2. What did I do? I messed something up there. The y is what? -1. I'm sorry. There we go. Okay, so all I did there was replace this x with 2, replace the y with -1, and I put them in parentheses so that I don't mess anything up. Now we've got to figure out what this is. What's 2 to the -1? That's really 1/2. We can use that property that I erased, right? That says if you have something to a negative power, you can rewrite it as 1 over that thing to a positive power. So I can rewrite that as 1 over 2 to the first power. I don't need to write the 1, but I'm doing it just to make sure everyone's clear. That's what happens here. And then this, what's this? +1, because it's -1 times -1. So this becomes times 1. And now this is really -3 times 1/2 times 1. Anything times 1 is itself, right? So that's really what I have. And then that's just -3/2. And we're done. All I did there was slid that up here because this is like a fraction. You just multiply across. We get that. All right? All right. Which one do I want to do next? I think these are all pretty straightforward. Let's do this. Let's do x, y. Let's go to the third. I'm going to change it. I'm doing problem 101, but I'm changing it up a little bit. So replace x and y, right? Replace x with 2, replace y with -1, and then raise that to the third. What would y'all do here? Anyone? You want to multiply this inside first? That's just what? -2. So you still have -2 in here, parentheses, cubed. -2 cubed means -2 times -2 times -2, -8, right? Three negatives multiply together, you get negative still. All right. I think those are doable. I'm not going to. Where are we at time here? 10 minutes? Yes.
Do one with square roots.
You want to do one with square roots? Yeah, why don't I just do number 105? I'll just do 105. X squared plus y squared. Remember, x was 2 and y was negative 1, right? Oh, negative 1. So I'm just going to replace x with 2 and y with negative 1. So x is 2, so 2 squared plus negative 1 squared. And then 2 squared is 4, right? And what's negative 1 squared? 1, positive 1. And that's just going to be the square root of 5. And that would just leave. Is it plus or minus square root of 5, or is it just square root of 5? Just square root of 5. When is it plus or minus? When you are working in an equation and you take the square root on both sides, which we haven't done anything like that yet, but the only time you get plus or minus is when you initiate a square root, which we will do later. All right, I'm going to look at one of these word problems. The instructions here are to express the statement as an equation involving the indicated variables. So look at 137 there. It says the area A of a rectangle is the product of its length and width. They want us to express that statement as an equation. The area is the product of length and width. What would I write down? Area A is the product of multiplication of length times width. So I can write L times W. That's it. That's all they want. It's just translating those words into an equation. Let's go ahead and do number 138. The perimeter of a rectangle is twice the sum of its length and width. Length and its width. So the perimeter of a rectangle is twice the sum of, so parentheses, L plus W. So these problems are just translating some words into a mathematical expression. So see how those work for you, all right? See how those go. The last part of this homework assignment has to do with scientific notation. And I'm not going to go over anything. I'm going to see if you all know scientific notation already. All these ask you to do is convert from scientific to regular and back. I'll give you one small example. How about that? If I take the number 4,257, how could I write that number in scientific notation? 4.257 times 10 to the third power. So it's just saying, if you take the decimal that was here and you move it 1, 2, 3 places and put it there, right, then you will write this times 10 to the third. What does 10 to the third really mean? 10 times 10 times 10, that's 1,000, isn't it? So isn't this just saying multiply that times 1,000? If you multiply that by 1,000, it's going to move the decimal point 3 places to the right. So it's just another way of writing it. That's right, it's just how many times you move decimal. So if I gave you this, you could convert to here, right, by moving the decimal? Or if I gave you this, you convert back this way. Now, if you start with a small number like this, 0.0352, to convert that to scientific notation, what you have to do is move the decimal to where you get right behind the first number, right there. So you get 3.52 times 10 to the, this time we moved it 2 places, but to the right instead of 2 places to the left, which means I put 10 to the negative 2. But what does 10 to the negative 2 really mean? 1 over 100, right? So isn't that just saying take that number and divide by 100, which would give you this? Okay, so I'm not getting too deep into the scientific notation. I want to see how you do on that. That's all you have for homework tonight, is just that 9.2 stuff. And again, I'm not collecting it, but bring it, right? Bring it, and we will move into the next sections of review, and then we'll eventually get into the new stuff, all right? Everybody have a great rest of your day. Hope it goes well. I'll hang out for a few minutes if you have questions. I ended a little early so that I can answer questions if anyone has any.